What if the most terrifying force in the universe, a black hole that devours everything, was something we could whip up in a lab, right here on Earth? Buckle up, because today, we're replunging into the heart of modern physics' wildest debate. Can we create a black hole? And what dangers lurk if we do? Hit that like if you're ready to stare into the void without blinking, as we unravel this cosmic thriller step by step. Let's break it open. Black holes aren't just sci-fi nightmares. They're real beasts born from collapsed stars, where gravity crushes matter into an infinitely dense point called a singularity, surrounded by an event horizon that nothing escapes, not even light. But the twist: physicists whisper about making tiny versions, micro-black holes, in particle smashers, like the Large Hadron Collider at CERN. Picture slamming protons together at near light speeds, energy spiking to trillions of electron volts, potentially warping space-time enough to birth these mini-monsters. It's like squeezing a balloon until it pops, but instead of air, you're compressing reality itself. The urgency hits home when you realize these aren't distant galactic oddities. They're theoretical ticking bombs we might ignite ourselves. Grounding this in fresh insights, a 2025 Johns Hopkins study suggests black holes could act as natural supercolliders, slamming particles at energies far beyond our machines, hinting we might harness or mimic them for breakthroughs. Yet, the peril: if one lingers, it could gobble atoms, growing unchecked, or so the fears go. X-threads buzz with debates. One viral post from July 2020 for arguing quantum effects like the Schwinger effect scatter energy before a black hole forms, making lab creation a bust. Scientific reports from CERN echo this, stating collisions mimic cosmic rays bombarding Earth daily, without swallowing our planet. Think of it as your body enduring a cosmic ray shower every second, harmless, yet packing the punch of a mosquito's buzz. But amp that up in a collider, and skeptics worry about chain reactions, where gravity's grip turns catastrophic. Diving deeper into where we stand, the human side brings this to life. Meet the trailblazers at CERN, folks like those who fired up the Large Hadron Collider back in 2008, hearts racing amid doomsday headlines. Remember the lawsuits? A handful of concerned citizens sued to halt the machine, fearing it would spawn a black hole that'd devour Europe. The tension was palpably engineers, triple-checking magnets, physicists poring over simulations, all while the world held its breath. Triumph came when protons zipped around the 17-mile ring without incident, but the near-miss vibe lingered. Fast forward to recent runs. In 2025, upgrades pushed energies to 14 trillion electron volts, probing for those elusive micro-black holes. No dice yet, but the data's gold, showing no exotic decays, bolstering safety nets. Humanize it with stories like Otto Rastler, the chemist who crunched numbers, warning of exponential growth, only for peers to counter with Hawking radiation, where tiny black holes fizz out in fractions of a second, hotter than the sun's core. Viral X clips capture the buzz. One semantic search pulls threads from astrophysicists sharing animations of evaporating singularities, racking up thousands of views as users debate, what if it doesn't evaporate? Reddit dives echo this, with users recounting 2008's panic, blending humor and horror in tales of black hole parties where folks joked about the end times. Then there's the breakthrough, ArcTeams, spotting gravitational waves from merging black holes via LIGO, inspiring lab mimics. A 2025 Oxford paper flips the script, proposing we use existing black holes as particle accelerators, detecting dark matter signals from their spins. It's not all smooth. Funding crunches and tech glitches, like a 2024 quench that halted beams, add tension, but rebounds show resilience. Drop in the comments, would you volunteer for a shift in a collider control room, knowing the stakes? Peering ahead, the implications spark optimism laced with caution. Tools like AI simulations are game changers, crunching petabytes of collision data to model black hole births in virtual realms. Imagine neural nets predicting if extra dimensions, those hidden folds in space-time lower gravity's threshold, letting micro-black holes pop up at collider energies. A fresh CERN report from September 2025 nods to this, with prototypes simulating quantum gravity effects that could unlock unified theories, blending Einstein's relativity with quantum mechanics. This might cure puzzles like dark matter's invisibility, or even tweak climate models by revealing energy from the vacuum. Skeptics pipe up, claiming tech's not ripe, energies too low. Risks too vague, but counterpoints shine. A 2025 MIT study on primordial black holes suggests their final bursts explain mystery neutrinos, flipping doubts with data showing safe, fleeting existences. Private ventures pour billions as X-threads from physicists highlight SpaceX-style colliders in orbit, dodging earthly dangers. We're talking progress that echoes humanity's fire-taming days tech's double-edged sword, where harnessing the void could power stars or unravel them. Yet, grounded speculation sees AI spotting signatures in real-time data, potentially confirming parallel universes if black holes decay oddly. Nature's hidden superpowers emerge here, like vacuum energy fueling infinite possibilities, turning what if into when. Now, let's vault into the bold what if, a scenario that pulses like a blockbuster but roots in today's edges. Envision a near-future lab buried under Swiss Alps, where a team led by Elena, a brilliant theorist in her 30s, tweaks the collider for one historic run. They've woven AI predictive modeling, outpacing rivals by forecasting quantum fluctuations with 99% accuracy. Day 0. Protons collide at unprecedented 15 trillion electron volts, and monitors flare a micro-black hole winks into being, smaller than an atom, its event horizon a whisper. Elena's team holds breath as Hawking radiation kicks in, the beast evaporating in a blaze of particles, but not before spitting data on extra dimensions. Tension builds in the control room, arms blare from a glitch, the whole lingering a heartbeat longer than predicted, gravity tugging at sensors like an invisible hand. Allies rally via global feeds, X buzzing with live theories from oceanographers to astronomers, crowdsourcing fixes that stabilize the field. Rivals scoff, calling it reckless, but Elena pushes on, her vignette, a race against entropy. Midway, a revelation. The hole's decay unveils dark matter's blueprint, a hidden ecosystem of particles revolutionizing energy zero-point taps that could fuel humanity forever. No fossils needed. As it fades, Elena collapses in relief, not defeat, her creation clocking mere femtoseconds but unlocking eons of secrets. This isn't pie in the sky, with 2025 prototypes hitting record simulations where strides from reality, where predictive prowess turns peril into promise. The event horizon beckons, but we're beckoning back, armed with intellect that's turning cosmic dread into discovery. Singularities untold in our labs whisper truths from the universe's birth, from ancient stellar collapses to today's proton smashes. Picture this, a flicker in the accelerator that defies gravity, echoing eons of cosmic drama. We're on the cusp, miss this, and you'll wonder what realities we left unprobbed. Tag a friend who needs their mind warped by these physics epics. This exploration shifted my worldview, underscoring that every probe into the unknown is a defiance of limits, a salute to our collective push for progress amid nature's fierce enigmas. Tech's double-edged blade carves our fate, but curiosity fuels the forge. Smash subscribe for more plunges into the improbable. Comment your craziest black hole theory below, and share this with your curiosity crewbie, 'cause the void's whispering, and who knows what revelations you'll unearth next.